So I'll be talking about building on Puppet. I hope that my next slides will not be cut off like these ones. So my name is Pedro Pessoa, and I'm also from Server Density. I will not tell you about it again, so David already did that previously. And I'll tell you, I'm going to talk about how we extended our own usage of Puppet, either from getting some code from the community and building some ourselves. So the first example that I have here is something that was mentioned before when we moved to the new load balancer for Server Density version 2. So we moved from Pound as a load balancer to Nginx, basically because of some features that Nginx has, and we needed it for version 2, and Pound doesn't have it. And we wanted to keep the way that we used Pound and how we integrated with our Puppet managed infrastructure. For that, we wanted the modules that manage Nginx pulled from the GitHub repositories, like all other modules that we use, like all other changes that we make, so that we can have the same workflow that was mentioned here before, like approvals and so on. And because we are Puppet Enterprise users, we wanted still to continue to use the Puppet console to manage our load balancers and to have the live management mcollective do the trigger of any transient changes that we need to do during operations, like it was mentioned by David before. So failing over nodes, adding nodes, removing nodes, and so on. We wanted still to do that from the Puppet console. So when we looked at replacing the load balancer and having some new manifests and some new modules built for it, we wondered if we would reinvent the wheel and write our own manifests and our modules again. Just as a note, we were doing that up to this point. So this was about 1 year or a little over 1 year ago. And everything we had on our Puppet master, we had written it ourselves. So the SSH manifest, creating the users, everything, we wrote it ourselves. And we had come to a point where we were looking around and seeing all this code written by someone else, and it was better looking than our own. And we wondered if we should follow the same procedure of writing the Nginx manifests and the modules, or seeing what was around available and try to reach the community and see what we could reuse, even most likely built by people smarter than us, and that had already solved the problem, had already gone through the pain of making it work. So we would use it instead of writing our own. This would prevent us from adding yet another module to our collection of already in-house developed modules. So what did you do? We went to the Forge. Actually, this presentation that I'm showing you here was, I already showed it in January at Ghent, and I actually had to replace this screenshot because one very interesting thing about the Forge, it is growing, I would say, exponentially. Because I had to replace it because when you don't see that slide, let me see, okay, let me see if I can, okay, because of this number here. In less than 10 months, it grew from 800 models to 1,700 models, which is pretty amazing. And if it was good then, it's even better now. So we went to the Forge, and we searched for Nginx. And we got a big list of matches. Actually, 1 year ago, it was less than this. It was 6, I think. So there's a lot more to choose now. And we went and see what people were doing with Nginx and Puppet. And you can go through all these projects and actually see the code, where it's coming from, what's it doing, does it solve your problem? And that's what we did. We took the first one in the list, and it could be a good choice as any. And then we started to see how we could integrate it into our existing Puppet infrastructure. So the first problem, or the first task would to get the actual code from the Forge into our Puppet master. And you can actually do that in two ways. Puppet has a way that you can actually run this command, and it pulls the module from the Forge, and it's ready to use. Or you can actually pull it from GitHub. So if you are using the Puppet Labs Nginx module, you just do that command on the same structure where you have all your other modules pulled from GitHub, and you would get it. We actually went with this second option, and I will explain why in a second. So the second issue would be to run it in existing nodes. So as I was saying, we are using the Puppet console, and we want it integrated. But there are no parameterized classes on the Puppet console, so how we would be able to feed the parameters of our load balancers into the module, which is parameterized. There is another option, actually, which is to merge the site PP, which is empty on the Puppet console. But this would add another knob, and we don't want other knobs on the Puppet master, so we went with this solution. I don't know if it's the best or not, but you guys can tell me. So we actually have our own class, let's call it Server Density Nginx, which incorporates the class coming in from the module. And then we parameterize it, and we integrate it with the console as a node classifier and get the parameters from the console right here and expand it like you already saw it before. And this piece of code is on our own modules, and it's static, so you don't ever have to touch it again. You create Nginx Rack, and you say that rack takes as many load balancers as you put in the console on this particular variable. So that's how we did it. And this allows us to keep the same workflow using the Puppet console as before, and allows us to bring in code that we did not have to write it all ourselves. We did not have to write it all ourselves, but we did extend it. And that's one also good thing about modules from the Forge, is that you can pull them down, you can extend it to for your own problem. In our case, we wanted better SSL support from the Nginx configuration, so we added that in, and we actually forked the module, and we are now using our own module, but it's public on GitHub, so everyone can also see it. Yeah, like I said, we could keep the same workflow of managing the load balancer, but I will go through this very quickly because you already saw it this morning. It's just a repetition. Just the thing that I want to show you is that you can actually edit that variable. It was one of these on the console, and then push it across the load balancers using mcollective through the console. So nobody has to actually get physical access, SSH access to the servers. Alternatives to this, like you saw, there are 25 other matches for Nginx on the Forge. So you could pick up any other modules. One interesting aspect that we learned after we picked the first one, that was the easy choice to do, was that it was actually already a fork from another module from the Forge. So you have to take a look at actually the history of the module to see, do I want this one because it already builds on the forked one? Do I want to go upstream to the original module? So look at the code and see what it does and how it works best for you. Yeah, so we ended up picking the later, and then we extended it and used it. So our extensions will show up on the slides once you get them. So it's on GitHub, and it's on the public repo, so you can take a look at it. So that was the very first thing we did about extending Puppet, and we took code from the Forge and extended it. Now I'm going to show you how we actually extended our product using Puppet. So these slides are getting a bit cut off, but you can see what's written. You can imagine what's written after that. So like it was mentioned before, our product collects server data from your servers using an open source agent that you deploy to each device, to each server. That's usually a manual job. You go there and you install our agent from the repositories. We have it on Ubuntu, on Debian, Red Hat, and so on. But that can be a manual task. And then once you deploy it and install it on one of your servers, you go to the server density UI and you actually create a device that represents that particular server or device. You copy a key from the UI to the agent configuration on the server, and then the agent reads the device ID from the configuration. It's something like this that you copied in, and it starts reporting back to our service. So obviously we want to automate this. So when you have a Puppet managed infrastructure, you want to automate all of this. So on version 1 of server density, what we used to do was going to the console. There's a specific node. You create the node on the server density UI. You get the ID and you put it in as the agent key parameter for a particular node. So you do this for every node that you have. And on version 2, we wanted to improve this. So this is the implementation, some of the implementation details of version 1. So basically, we have a package as the agent that we say ensure install. It gets installed. There's some preconditions to this, like setting up the repositories and so on. But it's not very important here. And then you get Puppet to configure it. So the configuration file gets created. So it's a file, and it reads in it uses a template that will read in that variable that got set up before. And this configuration file gets created with the value that you entered here on the console. So this is the actual bit of the template that does that. So it gets the key from the console on that node. And this creates, launches our agent, creates a configuration for it, and launches our agent. On version 2, we wanted to remove this still a bit of manual work from whoever has to set up the agent on our servers. And what we did, or what we aimed for, is that we no longer want to copy agent keys in. We just want either to classify nodes by groups, like we currently do, or most people should. I assume they are also doing it, and mapping that group classification to server density as a product, so that you can see exactly the same vision of your infrastructure in Puppet and in server density. So in our case, we had legacy groups, like with these beautiful names. We could actually use this immediately, and for example, this group contains the 50 or something servers that we have spread around the world to monitor the services from each location. So there are 50 servers here. You can see part of them here. And the only thing we want to do is to take the group name and actually automatically pull in all these servers and put them inside that group automatically. No agent keys moving back and forth. We almost did that. This is our live example of our infrastructure. Because we were not that smart in selecting group names to start with, we added another parameter with more readable names. So instead of all of this, we want this group just to be called actors. That's what they are. But if the original group name was already that, even this would not be necessary. And what happens now? So once you have this setup and you add a new class that we developed, and I will tell you about it next, what happens is that this is the server density UI. You have nothing. And after the first Puppet run on all those actors, you automatically get all this populated. So you can click on one of these nodes and you get the monitoring for it automatically. So no agent keys going back and forth. Everything already in their right place. So the actors group got created automatically also. And all of this was done when that first Puppet run happened on all of these 40 or plus nodes. So how is this implemented? One particular note, because you will see this in the code. So their server density version 2 also manages the life cycle of Rackspace and Amazon Cloud instances. We'll be adding more, but right now it does this. So you can actually, from server density UI, let me get out of presentation mode. So there's a little button here that says add a new cloud instance. And you can get Rackspace or Amazon instance powered up. And it should also automatically get the agent key and all this integration. And we do this using Puppet also. So a custom fact will return the cloud instance agent key. Imagine it here, the rest of the sentence. The custom fact gets the agent key. Or we'll use the server density API to automatically create a device on the fly and return the agent key when it's created. So we replace that manual step of going to the UI, creating an instance, with getting it automatically created on the first Puppet run using our API. So you can take a look at the code later. I'm just going to show you some snippets of it. So the fact, what we do. Here you see the three cases. Unfortunately, the cloud providers have different implementations of stuff, so we have to prepare for that. So this is the first case for Rackspace. On Rackspace, they have an API where you can inject a file to the cloud instance being created. So we can actually inject the agent key on the file system, so /etc/agent key. And if this exists, then we have a Rackspace instance, and we will just cat the agent key and return it. So we have the agent key from the fact. If it's an Amazon instance, we cannot do that. So we use their Meta API, and we inject the agent key on their Meta API, and then we query that for this particular host. We automatically retrieve the agent key again and return it. If it's neither of this, it's the case where you are using your own server, and it's not Rackspace nor Amazon, and you have to create the device on server density. And all of this comes together. That fact gets used on a custom function that we developed, which is, besides other things, it will take this agent key, which was the manual step of the thing, and build the configuration file automatically. This is the piece of code that does it. If the agent key was not looked up either from the cloud instances, it will mean that we need to create a device. And the device gets created using our API. So this is all the custom function code. It will call the API with a host name that you set up. And once that instance is created on the correct group, and you can set other parameters there, it will retrieve the agent key and use that agent key immediately to create a configuration file for the agent. So this is the rest of it. So the device was not found. It's automatically creating a new one and then retrieving the agent key from the device created. Our devices on server density, you can have nodes, and in this case we had a node that was created automatically by our module, so that you can tell them apart eventually if you want. Okay, and yeah, that's pretty much it in terms of code. So what's next? So this is actually available on GitHub, on this public repository. The next step is publishing to the Forge. It's not done yet because it needs comments and it needs some code compliance checks because it's not pretty yet to be published for the whole world to see, but you can already access it here. So it's fully working and our customers are already using it. Okay, so questions about what I've shown you? Yeah.
Did you fork this for existing module?
Not this one. So the first one was forked. This is a brand new one that we wrote. So we actually had two steps in extending Puppet. One was using already existing code and extending on it. And the next step was writing our own module from scratch. And this is the one that we wrote to extend our own product and to have our customers use it more easily when it integrates with Puppet. Okay. Okay, so. Yep. Sorry?
Why couldn't you get the Puppet modules you forked? Why couldn't you get changes into the upstream source?
Okay, so why did we fork it and not get it upstream? Well, actually, because some of the changes were incompatible with upstream. One of the changes, like I mentioned, was SL support, and we had to. So basically, Nginx forces you to choose several available configurations, and the one that was present in the original module was not the one that we wanted. So that's why we forked it and we changed it there, and then we extended it, and some other stuff is already available in there also. So, but that was the main reason, because some of the changes by our choice were incompatible with the upstream module. Sorry. Yeah.
I take patches. If you want to help sit down for a little bit,
Yeah.
you can work on getting that upstream.
Oh, sure. Yeah, okay. Am I missing someone else? No? Okay. Okay.